Yeah, thanks, Vijay. Thanks for reminding me to record it. Yeah, we'll start with the keyword super. So the super, it can be used in two different ways. So one is to call superclasses constructor. Okay, to call superclasses constructor, we will see why this has to be used. Okay, why we have to call superclasses constructor. Okay, then another way of using or other use of super keyword is to call superclasses members. Okay, to call superclasses members. That is, it could be your instance variables or your methods. Okay, it could be your instance variables or it could be your methods. We will see how that is done and why superclass constructor has to be called using the super keyword. Okay, so the syntax for calling superclasses constructor is super, and we will pass whatever the argument list that is there. Okay, and then the important condition about super is, why we use super is, super or the so say we have different classes, right? One is super class and another is subclass. Okay, so in order for you to create an instance of subclass, you must first create an instance of superclass. Okay, that is, superclass object must be first created, and then only you will be able to create a subclass object. Okay, that is why always in your constructor, subclass constructor, you should always, the first statement in your subclass constructor must be the I mean a call to super classes constructor. You must include the first statement within the subclass constructor should be a call to superclasses constructor. That is where we use this particular way of super keyword. Okay, that is one way. Another one is, if you want to call superclasses members which are hidden by your subclasses members, we can use this way. That is super dot member. It could be your instance variable or your methods. Okay. So here, this is similar to this keyword, and we will always use similar to this keyword, but we will always use this in subclass, and it always refers to the instance of. It always refers to the superclass within a subclass. Okay, is always used. So this is how we will use it. One is, this is the way, and another one is super dot member. Okay, we will see some examples on how we can use super. Okay, so as we have mentioned, subclass, before, I mean, when you construct a subclass object, the superclass object will be constructed first, and then only your subclass object will be constructed. Okay, let us see an example why that happens, and let us see. Okay, this one. This is a default constructor. We don't have any parameters to this particular constructor, right? So let us see whether we have. Yeah, here we have here we have one more superclass which has a default constructor. Okay, and we have one test class in which I'm just creating one instance of subclass. Okay, hope all of you are able to see my screen. Please let me know if you have any issues seeing my screen. Okay, all of you are able to see my screen. Okay, yeah, thanks, Kavita. Okay, yeah, thanks. Yeah, so what am I doing here? I'm just creating an instance of subclass. Okay, let me try to run this program and see what exactly happens. Okay, so if you see the output here, first superclass constructor is called. Okay, that means your superclass object is created. Okay, and here then your subclass object will be created. Okay, so this is a must. So that is why. So what exactly it means is, say for example in inheritance, right? You have superclass and you have subclass. Okay, subclass, you cannot create an instance of subclass without creating an instance of superclass. Okay, so whenever you create a subclass, so what do we use to create a or create an object? We use constructors, right? We use constructors to create instance of a particular class. So you will have constructors for super, you will have constructors for subclasses. So when you call a particular constructor, the first statement, say for example, you have you have subclass here. Okay, so this is your constructor. So the first statement within your subclass constructor. Okay, the first statement within your subclass constructor must be a super call to. This is nothing but a call to superclass constructor. Okay, it must be a call to superclass constructor. So here what is happening? I have not made any explicit call to superclass constructor, but when we run this program, the default constructor of superclass is called, invoked. Okay, the default constructor of superclass is called. Okay, so this is what is your default constructor for superclass. So that is what is called when you don't give any, when you don't mention any, when you don't call any superclasses constructor. That is what is taken care by Java when you don't mention anything. So this also can be written as like this one. Okay, this is also true. So what you are doing now is you are explicitly calling. By doing this, you are explicitly calling the default constructor of your superclass. Okay, so assume that I have overridden or I have overloaded the superclass constructor. The overloaded method, overloaded constructor takes one overloaded method constructor takes a string argument, a string parameter. Okay, so if I want to call this constructor, what I can do is I can directly call either this one. Okay, so now this. Okay, now what am I doing? I'm calling. Sorry, I'm calling the superclasses constructor that takes string as a parameter. Okay, that takes string as a parameter. So then this particular constructor will be called. Okay, so what happens if we don't have default constructor here? Okay, let us try to comment this. Let us comment this and see what exactly happens. Okay, Okay, so comment this part. Okay, say now it is showing error. Okay, because here if you don't mention any constructors, if you don't mention any constructors here, then if you don't mention anything, default constructor will be provided by Java. Right? Default constructor we've already seen. If you don't mention any, or if you explicitly don't mention any constructor, Java will provide a default constructor for us. Right? So here, what is happening? I don't have any constructors defined here, so Java will provide me a default constructor without any parameters. Right? So now here, what am I doing? This is sorry. This is your subclass, and the main rule is the first statement within your subclass constructor. The first statement within your subclass statement must be subclass constructor must be a call to superclass constructor. Superclass constructor, a call to superclass constructor. Okay, this is very important. So since we don't have any constructor here, and default constructor is provided by Java, here by default a call to superclass constructor will be inserted, or Java takes care of inserting call to superclass constructor, that is default superclass constructor. Okay, this is valid. In this case, if you try to run this particular program, what happens? It shows only subclass constructor. Okay, it shows only subclass constructor because we don't have any constructors defined. That is okay. So that is valid. We can easily see that particular thing happening here with this statement. Okay, with this println statement. When we run this, okay, when we run this, superclass constructor will be called first, and then subclass constructor will be called. Okay, but when we have this one, and if we don't have default constructor, okay, if we don't explicitly specify, or if we don't explicitly call the constructor, okay, here we don't have any default constructor. As soon as you specify one particular constructor with anything instead of your default constructor, Java will not take care of, Java will think that you know how to construct an object. Okay, Java thinks the moment you construct one particular or you write one particular constructor for a particular class, Java assumes that you know how to construct a particular class or object of that particular class. So it won't give you default constructor. If you want default constructor, you can explicitly specify like this, how we have done it here. Okay, but if you want it, this depends on your requirement. Okay, so otherwise, if you have only this one, and if you don't specify or if you don't call superclasses constructor as first statement in subclasses constructor, it will start complaining. Java will start complaining. Okay, implicit super constructor superclass is undefined. Okay, implicit super constructor superclass is undefined. Must explicitly invoke another constructor. So that is a rule. Okay, it is like we must insert. We must the first statement must be Okay, so in order to avoid this particular error, what we can do is we can uncomment this particular part. Okay, so as soon as you mention that, as soon as you call a constructor which takes string as a parameter, the error is removed. Okay, and then what happens if you run this particular program, the particular constructor will be called. Okay, this is how we can use super to call super classes constructor. Okay, this is how we use. This is one way of using your super keyword. Okay, this is one way of using your super keyword. Let us try to have one instance variable. Okay. Okay, and then let me have 20. So let me try to observe that here also you have integer I, and here also you have integer I. Okay, but in superclass the value of I is 10, in subclass the value of I is 20. Okay, you can see this value of I is 20. So
Muted. Muted.
I got disconnected and connected again. Okay, so what I was telling is, so in subclass we have the value of I is 20, and in superclass the value of I is 10. Okay, so let us try to display that value here. Okay, let us try to run this. Okay. So it shows that the value of I is 20. Okay, so what if you want to print the value of I in your superclass? Okay, okay, this here we cannot call. We can call here. Okay, we can call within the subclass. We can call, or you can reference the value of our instance variable using super.i. Okay, so one more example is say for example, you have display method which displays your value of I. Okay, this is in our superclass. No, you cannot call like that, Kavita. That's what I tried, right? So you will not be able to call that way. So here you can call this way, superclass value of I. Superclass value of I. So it is defined in superclass, okay, and the value of I, okay, and then you can have, okay, okay. So if you want to print the value of superclass is I, you can use. That's what I did in this one, right? This particular, okay. Subclass super.I, okay. This is super.I, okay. And then what you can do is printing. Let us have the super.display, okay. Yeah, Kavita is telling super data in within, no, that is what is the main thing, right? So you cannot call super in any of the other classes, okay? Subclass, within subclass you can use super like this to call your superclasses members. Okay, this is calling your instance variable. This is calling your super classes, one of the method. Okay, so if we try to call display, if we try to call display on superclass subclass, okay, so it will display both the values. Okay, let us comment this part. So you can see the output here. Okay, the first your superclass constructor is called, and then subclass constructor is called. We are displaying the value of I in subclass because that is what is done here. This particular okay, in this subclass. Okay, this is what we are doing first. Subclass I and then superclass I by accessing the member, the instance variable here. Okay, that is what is being done here. Okay, and then we are calling the superclasses display method. We are calling superclasses display method. That is superclass value of I. Okay. So, did you all check Yuvraj's email? Today also he sent and yesterday also he has sent an email. Did you all check? Like today's class was supposed to start at 8 o'clock, so and that's what I wanted to inform. Okay. And one more thing is tomorrow there won't be any class. Sunday we will have two classes. One is at 10:30 to 12 and evening 8 to 10. Okay. Tomorrow there won't be any class. Okay. So that is how we can use super in two different ways. One is to access your superclasses members, and another one is to call superclasses constructor. Okay, to call superclasses constructor this way. Okay, this is one way, and this is other way of using it. Okay, so let us continue. So anyone has any questions regarding this one? Okay, so that is what we've been discussing, right? the constructors, how the constructors will be called with respect to inheritance. Okay, the constructors are called in the order of derivation. So that is what is, first the superclass constructor should be called, and then your subclass constructor should be called. Okay, the main logic behind this is, it is like this. So without our parents, we will not exist, right? So first the parent should exist, and then only we will exist. This is the logic behind your first, why the first statement of subclass constructor should be a call to superclass constructor is, this is the reason. Okay, superclass should be constructed, superclass object should be constructed before your subclass object is constructed. Okay, that is why this is also like the order of derivation is also like that only. It should be like that, superclass and then subclass. Okay, that is why we always have to, or we must always have the first statement as call to superclass is constructor, superclass is constructor. Okay, so if we don't use the superclass constructor, Java will insert super default call to default constructor of superclass. Okay, that will insert. We have seen that example as well in our previous thing. Okay, so let us move on to what is inheritance. Method overriding. Okay, so what is method overriding? The main important thing with respect to method overriding is this particular thing. The name of the method and type signature must be same. Okay, name of the method plus the type signature. Type signature is nothing but your parameter list. Okay, it does not include your return type. Okay, it does not include your return type. Type signature is your parameter list. Okay, say for example, there is a class called A, and I have method display which takes string. Okay, and I have method B which extends A, and it also has method display. Okay, and string, it also takes a value, a parameter of string. Okay, so this is when we call methods are overridden. Okay, this is when we call methods are overridden. Say for example, I have A, class A. Okay, display here. Okay, and B extends A. Okay, here also I have display. Assume that the return type is void. Okay, and I have display method here. So will this be called as with this definition, with this particular definition? Okay, with this particular definition, will this be called as method overriding? Vijay, Kavita are telling no. Why? Why this is not called as method overriding? Why this is called as method overriding? Why it is not called as method overriding? So then what is this called as? Okay, so it should be same. Kavita is telling it should be same. Okay, great. Yeah, Kavita is telling this is called as overloading. Okay, let us see that example. Okay, so I have, let me take this one only, superclass. Okay, so I have this display method. Okay, which displays the value of I. Okay, in subclass also I have this method. Okay, what am I doing here? So the signature is same, right? This is a public void display method, and this is also public void display method. Here also display does not take any parameters. Here also I have not mentioned any parameters to your method. So this is what is called as your method overloading. The signature should be same. That is your name of the method and the parameter list. Okay, name of the method plus parameter list. Okay, they must be identical. When they are identical, what is it called? Okay, they are called method overriding. Okay, so let us define another method here. And let us define another method which takes a string. Okay, so now what we will do is okay. Now what do we have? We have two methods. One is without any parameters. Another one is with parameter. Okay, which takes a string argument. Okay, string parameter. So with respect to subclass, this is overloading. And with respect to superclass also, this is overloading. Okay, in both the ways. Within subclass, I have overloaded. With respect to superclass also, this method is overloaded. Okay, but this method, with respect, which does not take any parameter, is overridden with respect to superclasses constructor. I mean the method, display method. Okay, superclasses display method with respect to this particular display method. This method is This method is overridden, but this method is overloaded with respect to this method as well as this method. Okay, so did you understand the difference between overloading and overriding? Overloading and overriding. So the main difference between overloading and overriding is, okay, overloading, same name, different parameter list. Same name, different parameter list. Okay, this is overloading. Okay, overriding is same name, same param list. Okay, so the interesting thing here is, can you have other method with the same name here? with the same name here? Can we have like that? No, it is not allowed, right? So overriding happens only with respect to your inheritance. Okay. Overriding is only with respect to your inheritance, but overloading is same. Like you can have one method with name display in a superclass, okay, which does not take any parameter, but display with any other parameter is called as overloading. Why is that? Why do we call that as overloading with respect to a subclass? Because we have seen, right? So this particular any public members, any public members, right? They are like it is like here we have defined it is like this one only, okay. But this one, this with this definition, it appears here. It is like that only, okay. Forget about this, okay. With this definition, it by what you say, it virtually appears like this, okay. This particular public member, right? This is a public member. This is like included. This particular definition is included inside your subclass, but you will not be able to see because of inheritance, okay. Because of inheritance, it is like that only, like this particular method display without any parameter with this definition, right? That definition is here, but you will not be able to see because we have extended this particular class. It is like that only, okay. So with respect to your superclass also, this is overloaded, or with respect to your subclass also, this is overloaded, okay. Okay. So whenever you call a overridden method, whenever you call a overridden method inside your subclass, okay, whenever you call an overridden method inside your subclass, within your subclass, it always refers to the method that is defined inside your subclass, okay. It always refers to the method that is defined inside your subclass, okay. Say for example, I want to call this particular display method, okay. So observe what is happening. So let me make one small change here. Let me comment this one and comment this one, okay. So now what do I have in this particular display method? Displays superclass value of I, and this particular method displays subclass value of I, okay. Now what am I doing? I'm calling display method on subclass object, right? This is your subclass object. So which method will be called? It always refers to the definition which is there in your subclass, okay. So we've briefly tried to understand this one yesterday. We'll try to explain more, okay. This. So this is the subclass version of your display method. So when you call on subclass object, the method that is called is your subclass version of your display method, okay. That is what this one says. This one says. So we also know, yeah. So we've already discussed this as well. Okay. To access the superclass version, we can use super dot display. Right. We've also seen that. We've seen that. Let us try one more time. Okay. So here, come here, and then uncomment this part. That will call your superclasses display method. So we will be able to see both. Okay. Subclass value and superclass value as well. Okay. Let's move on to the next one, next slide. Give me a second, guys. Oh. Sorry, can you all hear me now? Yeah, Tina. Can you all hear me now? Okay, yeah. Yeah, thanks. Yeah, Tina. Hello, can you all hear me? Can none of you confirm that you can you all hear me? Okay, yeah. Thanks, Kavita. Thanks, Vijay. Yeah. So what were we discussing about? Oh, okay, so that is what. So whenever we say dynamic, that is your runtime part. Okay. So dispatching is nothing but resolving call to a method. Resolving call to a method. How that method dispatch is done? Call to a particular method dispatch. Okay. How that call is resolved when you call a particular method. So in case of subclass, when you call a method, that is your display, Java knows which particular method to call. That is, you're calling on subclass, and the display method is overridden, right? So subclass object and display the version of method that is called on subclass object is the subclass version only. Okay, the subclass version only, right? So the Java knows it won't depend on runtime. So when you call on subclass, it knows which method to call. Okay, so methods are resolved in Java. All the methods are resolved at runtime. Okay, method calls are resolved at runtime. This is called as late binding. Okay, this is called as late binding. There is also one more method dispatch is there, that is your early binding. Okay, we will see what is that early binding and when that early binding happens. Okay, but all the methods are resolved at runtime. Okay, Java resolves all your methods at runtime. That is why it is called late binding. Okay, late binding is nothing but methods are dispatched during runtime. Okay, but this is when your even with your inheritance, it happens the same thing. But the main important point is, yesterday when we were discussing about this particular point, right? This is very important and very interesting point. That is, when you try to call a method, on superclass reference variable, okay, which overridden method is called. Okay, that is the important thing. Okay, so the method that is called is, the version of method that is called depends on your, as we discussed in last class, the type of the object. Okay, the type of the object determines which overridden method is called. Which overridden method is called. Okay, let us see that example. We have seen that example in last class, if I remember correctly. What is that shape? Is it? Okay, so here itself we can see that one. Okay, so we have display method in subclass as well as superclass, right? So let us construct one superclass. Okay, and then okay, then dot. Okay, this is one. Then what we will do, obj is equal to, we are assigning subclass object. Now we are calling the same thing. Okay, let us run this program. So let us stop this one. So now you can see we are calling superclass constructor with string. This is what is passed here, and then we are calling superclasses display method. So this particular, it displays this particular message, that is superclass value of I is 10. Okay, then what we do, we assign subclass object reference to superclass reference variable. Okay, now this reference variable is referring to subclass object. Okay, this is very important. Okay, this is very important. Now this is referring to subclass object. Okay, so what are we doing? This refers to subclass object. It is pointing to subclass object. That is why when we call this, this is nothing but your subclass calling your display method on your subclass object. That is why it displays this one and then this one. That is what is the definition of display in your subclass display method. Okay, this is how Java resolves method calls when you try to call overridden method using superclasses reference variable. Okay, this is nothing but runtime polymorphism. Okay, this is called as runtime polymorphism. Okay, why runtime polymorphism? What is the definition of polymorphism? We'll have one interface but multiple methods. So the interface which we are talking about here is display. Okay, display, but it has different definitions, right? It has different definitions. One definition in your superclass and another definition in your subclass. Okay, one definition in your superclass and one definition in your subclass. That is the interface. With the same name, we have different definitions. One in superclass, one in subclass, right? And using dynamic method dispatch, respective method is called. Which method is needed? That particular method is called. Okay, that respective method is called. That is why this is called as runtime polymorphism. Through overridden methods, Java implements runtime polymorphism. Okay, what is the main advantage of this one? So, what are we trying to do with this runtime polymorphism or with overridden methods? Say, for example, you already have one particular class. Okay, you have this particular class. So somebody has written this superclass. Somebody has written years ago. Okay, and today I came and I wrote this particular method, that is subclass, that is which extends from your superclass. Okay, which extends from your superclass. So I know the definition, what are all the interfaces that are available within your superclass, but I don't want to use this one, this particular method. I want to override that method and use that method. Okay, so what am I doing here? This is my, forget about this. We will talk about this part. Okay, this is my old class object. Okay, this is my old class reference variable. Okay, and this is my new class, and this is the definition, new definition for the same method. Okay, new definition for the same interface. So what am I doing here? On superclass object, which was written 100 years back, I'm calling subclasses method. Superclasses reference variable. On superclasses reference variable, I'm calling subclasses method. Okay, I'm calling subclasses method. I can go ahead and write one more subclass which extends a superclass or which extends subclass, and I can call on this particular subclass superclasses or reference variable. I can call subclasses method. Okay, I can call subclasses method. Important thing is I'm not at all touching the superclass. I'm not at all recompiling this recompiling superclass. Without recompiling superclass, I'm calling subclasses method. right? That is why it is very powerful and it's called as runtime polymorphism. So through overriding, Java implements runtime polymorphism. Through overriding, Java implements runtime polymorphism. Okay. Okay. So let us start with the abstract classes. Okay. What are abstract classes and why? Why abstract classes? Okay. So abstract classes are nothing but a class that has at least one abstract method, at least one abstract method. Okay. One or more abstract methods. So what is an abstract method? Abstract method is nothing but a method with just a declaration. Okay, with just a declaration. Excuse me. It will not have definition of that particular method. For example, earlier we had a method, right? Public void display. Okay, we had some. It had body. It had some definition within its body. Okay, but this is not an abstract method. So the abstract method is the method which does not have a body associated with it. It will just be having parenthesis, and then we will close that one. So if you see this, this is your access specifier. We will use the abstract keyword, okay, and then the return type of the method, and then your identifier. So if we write this, or if you want to make this particular method abstract method, we will write this way: public abstract void display. Okay, public abstract void display, but we don't specify the body for this method. We don't specify the body for this method. This is what is your abstract method. So this is called as modifier, which modifies the definition of this particular method as abstract. So this will not have just the body, it will just have the declaration. This is called as the declaration of your method. Okay, this is the syntax for your abstract methods, defining your abstract method. Okay, you specify the access specifier, use the abstract keyword, then the return type and the identifier, open and close parentheses. You can have parameter list also. You can have parameters list also. Okay, but it will not have the method body. Okay, so any class that contains at least one or more abstract methods, any class that contains one or more abstract method, that particular class is called as abstract class. That particular method is called as abstract class. Okay, abstract class, the definition also you should use for defining abstract class. You should use abstract keyword. Okay, similar to that one, similar to your abstract method definition or declaration. This is your access specifier. We use abstract keyword, class keyword, and then the identifier, class body. Okay, so this must have at least one abstract method. This must have at least one abstract method. Okay, So let us see an example why we use abstract methods or abstract classes also. So we have one particular class, okay, that is your figure, okay. It has getters and it has one particular constructor which takes length and breadth, okay. As of now, we don't know what is that particular figure is, okay. So we use this as superclass for defining a rectangle, okay. So rectangle extends figure. So here we have defined figure area for this particular figure. So we don't know what is the figure at all, but we have this definition which returns 0, okay, which returns 0, and this figure will not have any specific area because this figure, we don't know what is this figure, right? So we define two classes based on that one. One is your rectangle, okay, and another one is your triangle, okay, another one is your triangle. So rectangle area is length into breadth, and that triangle area is length into breadth into 1/2. That is length into breadth by 2, right? But what is this one? So we have just defined this particular area method here, just as kind of like a dummy method, right? We have defined this as a dummy method because we don't know what is this figure. We cannot calculate the area of this particular figure, right? So we don't know what are the dimensions which are used for calculating the area of this particular figure, right? So in such scenarios, what we can do is we can just get away with this particular definition, okay, and we can define this one as abstract, okay. As soon as we define this one as abstract, you see that it starts showing error here, because if you have at least one abstract method, the class must be abstract, okay, the class must be abstract, okay. The class must be abstract. So can we have, okay, let us try to declare, this is Kavita is telling like base class. Yeah, it is like a base class. Yeah, it is your super class only. This is your super class only. The base class is nothing but your super class only, right? This is your super class only. Because you are extending figure in your rectangle as well as your triangle, right? This is your super class. But this is just abstract because one of the method, right? One of the method here is abstract. Abstract in the sense it will not have any definition, because you cannot define or you cannot give a meaningful definition to this particular method, right? So it does not make sense when you write like this, area of figure is undefined and it returns 0. It does not make any sense, right? In such scenarios, what you do, you just make that particular method as abstract and extend it in your subclasses. Okay, this is your subclass which extends, and this is your another subclass which extends figure. Okay, let us try to comment this one, this part. Let's see what happens. Okay, so what happened? It is showing error. So it says add unimplemented methods. Add unimplemented methods. It shows add unimplemented methods. So abstract class, what is the constraint with respect to abstract class? What is the rule which we must know? Remember, whenever you have an abstract method, you must define, you must provide a definition to You must provide a definition. You must define this particular abstract method in your subclass. Okay. So here rectangle has defined area properly. So what is the area of rectangle? We know what is the area of rectangle, length into breadth, right? But here we have not defined it. That is why it is showing error, compile time error. Okay, it is asking us to implement abstract method. Okay, so what it forces your subclass to do is, abstract method is, it forces subclasses to implement that particular method. Okay, so can you get away with without implementing this particular method in subclass? Yes, you can do that. But in order to do that, what you have to do? You have to make this subclass also as abstract. Okay, you have to make this subclass also as abstract. See, now the moment I made this particular subclass as abstract, the error on this particular class is removed, right? The error on this particular subclass is removed. Any subclass of triangle must implement the area method. Okay, because this is abstract and its superclass is also abstract. So this has not defined area method. Okay, that is why any subclass of triangle, say for example, right angle triangle extends triangle. So this is a subclass of triangle. So here I should provide a definition. Okay. So it does not take any parameter. We have to provide a definition to this particular subclass, that is right angle triangle. Okay, triangle, right angle triangle extends your triangle. So we have to provide this particular method. Otherwise, we can modify this as abstract class, right angle triangle. So in that case, you may not have to provide the definition for area method. Okay. Did everyone understand what we just discussed now? Is it clear? Is it clear to everyone? Okay. So let's move on to the next topic. Next slide. So we have seen the final keyword, right? We have seen final keyword. So when you apply final to instance variable, you apply final keyword to instance variable, what happens? When you apply final keyword to instance variable, you cannot change that value. You cannot change the value of that instance variable. That means that instance variable is nothing but your constant. It becomes constant. That instance variable becomes a constant. So final variables are constants. You cannot change. You cannot change them. Okay, but there are other places where you can use your final keyword. Okay, two methods. Okay, so you can define one particular method. Say for example, public void final void display. Okay, so you can apply the final two methods as well as classes. Okay, when you apply method, when you apply final to method, you cannot override that particular final method. Okay. When you apply final to classes, you cannot inherit that class. You cannot inherit that class. Okay. So let us see a couple of examples. Okay. So final, what we can do, figure test. Okay. So let us do this one. Let us take these two examples only. Okay. Superclass. Okay. Let us define one particular method. Public final void this is final method. Okay. So what am I doing? Okay. This is a final method. So let us try to override this method. Why is this showing error? Okay, you cannot instantiate. Okay, forget about that. So let us try to override that method. So it is the same name, right? Same definition. Okay. So we are not able to do it because this is a final method. So we have used the word keyword final here. We've used the word final. This is your Java keyword. So this makes final. So what does that mean? It means final methods cannot be overridden. Okay, final methods cannot be overridden. That is what we are seeing here. So if you try to override this particular final method, it clearly says you cannot override that particular method. So yeah, if you hover it, it shows remove. It shows a remove final modifier of superclass dot use this final method. Okay, it clearly says remove final modifier of superclass. This is final method. So what it is saying, just remove this final keyword in order to override that method in your subclass. So that is why final methods cannot be overridden. There may be scenarios where you don't want your methods to be overridden. Okay, so somebody would have written a method which is which he or she thinks that it is the optimal implementation of the particular method. So you cannot go beyond the efficiency of this particular method is very well, or if this particular method is it should not be redefined, or you don't want any other people to subclass the particular class in which he or she has provided final method and override it. Okay, he or she doesn't want a particular method to be overridden. That is the final method. Okay, you cannot override it. So that is the final definition. So you cannot override it. Okay, that is what it means. So the third The third way of using your final keyword is on classes. So let us try to define one particular final class. Okay. So this is your final class. You can make it as final class. Okay. This is your final class. So let us try to subclass this final class. Okay. Can you do it? No, it shows error. Okay, it shows error. It says remove final modifier for final class. So if you want to subclass this final class, you have to remove this particular modifier. Okay, you have to remove this particular final modifier. Otherwise, you can't extend this particular class. Okay, so this is also similar to your final classes. So one of the final class in Java is a very popular final class is your string class. Okay, string class is implemented as final class. All the methods inside your string class is final methods. Okay, you cannot extend the string class. So let us try to extend string class. Okay. You'll not be able to subclass a string class. So whatever the definition provided for each and every method in string class is final. You cannot extend string class and override any of those methods. Okay, we will see that one in our future classes. Okay, in our later classes. So you cannot what happens in such cases if you are if Java developers were given permission to change the implementation of string class, n number of the people would have implemented string in different ways. Okay, that would have confused different versions of Java, which comes from that particular this one. What is that particular company? So in such scenarios, right, we make a particular class as final so that it won't create any confusions to people, Java developers. Okay, so in such scenarios, whenever you apply final means it is the final definition of that whatever the identifier on which you use it. For instance variables, it becomes a constant. You cannot change the value of the instance variable once the value is assigned to that final instance variable. Okay, and then for final methods, you cannot override it. Whatever the definition that you provide while defining the final method, that is the final definition. Okay, for final classes, you cannot you cannot inherit it. So that whatever the definition that you provided for that particular class, that is the final one. That is the meaning of your final keyword with respect to your instance variables, methods, and your classes. Okay. So I have one question. So we have not extended any class for this particular class, right? This is on its own. So is there any other class which is a super class of this particular class? Is there any class which is super class of this class? Can anyone tell? Yeah, he knows. You answered it. Okay, good. So does anyone else know? Is there any super class of this particular class? Yeah, Suresh. Yeah, there is one special class. Okay, there is one special class that is called the name of the class is object. Okay, the name of the class is object, which is Java provided class. Okay. So this is what is the importance of this particular class? What is the importance of this particular class? Give me a second. Oh. Okay. So what is the importance of this particular class? This is a super class of all Java classes. Okay. This is a super class of all Java classes. We don't specify with extends keywords though. We don't specify that with extends keyword. Okay. We don't specify that with extends keyword, but this is a super class of all your Java classes. Okay. All your Java classes. So what does that mean? Object is a super class of all your Java classes. So what does that mean? A reference variable of object class can refer to any objects in your Java world. Okay, say for example, you have ref is equal to, you can assign an object of okay, it can be any object in Java world. It can be any object. So this is a reference variable of type object. This particular reference type can be assigned an object of any type in Java. Okay, even the type that you create, user defined types, new type, any type. Okay, user defined types, any user defined types. Okay, let us see an example. Okay, here itself. Okay, so here itself, super class test, super subclass test. Okay, so let us see object is equal to okay. Okay. Right. Okay. Excuse me. Okay. So we can. This is a reference variable of type object. Okay. You can assign any object. Any object you can think of in Java. Any object you can assign it to that particular Java object variable. Okay. So we have concluded. We come to the end of this particular session. So if you have any questions, please let me know. Okay. So Anyone has any questions? Please let me know. Otherwise, we can wind up this particular class. Okay. Before we conclude this class, I have few URLs. Okay, so that you can refer to these URLs for any Java exercises. Okay, any Java exercises. So these three are the URLs you can refer for practicing whatever the topics that we have discussed. Okay, so particularly this last one, right? It is related to one particular university, so it has a good amount of bit complex exercises. Okay, you can try to go through those things and try to implement those logics or whatever the logic they have explained. It is bit they have given some mathematical formulas also and some challenging exercises. Okay, try to do all those exercises. So in that way, your logical reasoning and your programming skills, everything will improve. Okay, these are the three links which you can refer for your practicing your Java knowledge. Okay. Yesterday, one of the participants was asking for these links, so I thought I'll give this. I'll share these links with you all. Okay. If anyone has any other questions? Okay. Yeah, thanks everyone for attending this session. We'll meet on Sunday. There will be two sessions, morning and evening. Okay, morning 10:30 to 12 and the evening 8 to 10. Okay. Thanks a lot, everyone. Thanks. Have a great evening. Bye bye.